Okay, guys. Lesson 8.1 is inverse variation. Okay, inverse variation. You would have, well, you possibly talked about in Algebra 1. It's also possible it was a skipped topic. Okay, because it is borderline topic-wise whether it fits into the standards or not. So, we did earlier this year, I believe, talk about direct variation. Would have been a first semester chapter. So this is inverse variation as our focus. Now, we're going to talk about them together. It's just we are including inverse variation. So, some information here. Direct variation. When a problem talks about direct variation, you will often see the words given, x varies directly as y. And when we see something that says x varies directly as y, we are looking in the form of y equals kx, where it's y equals k, which stands for a constant, times the variable x. Okay, so that should sound a little familiar from somewhere. Yes, maybe. I know I've taught it this year. So direct variation, the equation is y equals kx. The words x varies directly as y. The other version of the equation that we also sometimes use is if we take this equation and solve it for k. We solve this equation for k, that's dividing by x. And so then k is equal to y divided by x. So when we talk direct variation, those are the two equations you need to become familiar with. Inverse variation. Well, instead of varies directly, it's going to say varies inversely. So given x varies inversely as y. Now, I know there's a typo in one of these I have to fix. I'll fix it when I get to it. The primary equation we're going to use is y equals k over x. Okay, so direct variation is a multiplication relationship. Y equals a constant times x. Inverse is a division relationship. Y equals a constant divided by x. If you solve it for k, so since it's k divided by x, if you multiply that x over, the solve for k version is k equals x times y. And those are the two versions I most often use. This other version, there's a typo in it because for one, if you notice, it's two x's. The other version could be written as x equals k over, and that would be a y. I don't usually use that one too much, okay? I use the equations that are y equals or k equals. You don't usually see the x equals. Okay, so kind of work on committing those to memory, becoming very familiar with them for direct and inverse. Now, we have several things we're going to do with direct and inverse. One of these, we did this with direct variation, I'm pretty sure. Looking at a table of values and deciding, is this an example of direct variation? Is it an example of inverse variation? Or, option 3 is, fits into neither category. It's just a random list of numbers that's neither direct nor inverse relationship. So, looking at example A there. Ordered pairs 2, 10, 4, 8, 10, 3, and 15, 1.5. Thoughts on how we can decide? How we can decide if this is direct variation or inverse variation?
Divide.
Do what?
Divide.
What do you mean divide?
Divide by x. Like divide all of them.
Like do y divided by x?
Yeah.
Okay, so if we do y divided by x, then what we're checking for is this direct variation? Okay, and I agree, this is one of the things we need to do. So let's check and see what happens when we do y divided by x. Because when we're doing y divided by x, that's finding my k value up here on direct variation. So What happens on the first set? 10 divided by 2 is 5. What happens on the next set? 8 divided by 4 is 2. Any thoughts at this point?
It can't be direct variation.
Okay, it can't be direct variation because, okay, that k is a constant. It needs to be the same every time. As I go through and start dividing these, 10 divided by 2 is 5. That means if these all match, they all need to be 5. Or if 8 divided by 4, if this one's 2, then they all need to divide to be 2. So, right here, because my 5 and 2 are different, this tells me that this is not direct variation. That's what I know at this point. Am I done? Whoops. Now, what should I check now? Inverse. What should be true if it's inverse variation? If it's inverse, k is found by doing what? Multiplying. So let's try some multiplying of k equals x times y. So my first set is going to be 10 times 2, which is 20. And what's my next set going to be? 8 times 4, which is 32. What do I know? Because 20 and 32 resulted in different results, I know that this is not inverse variation. So what is it?
No.
Our best answer is neither. Okay, so the two things you're checking, guys. If my numbers divide and I always get the same, we're going to have an example of direct. If my numbers multiply and I always get the same, I'm going to have an answer of inverse. If neither happens, then it's neither. It's not direct, it's not inverse, it's just a random set of ordered pairs. What? No. Well, I don't think it can. Trying to think if there's any special cases. Ooh. No? I don't know. I don't have any. I'm trying to think if there's any special cases. I don't have any examples planned where it's both. Are there any special cases out there where maybe it could be both? I'm not sure. I don't think so, though. I really don't. Nah, the more I think about it, no, it's not good. There's not an option for both. Sorry, have to process. Good question, though. Okay, so B. What are you guys thinking in B? What should we try doing?
Wow.
You want to try multiplying or dividing them first? Multiplying them? I mean, you know, save your energy here if you can kind of identify this just by glancing. Okay, if we multiply, what is 2 times 15? 30. Okay, this is the one that's probably making you think a little harder. What is 4 times 7.5? 30. Because 2 7.5s are 15, and so 4 of them make 30. What's 10 times 3? 30. What's 15 times 2? 30. Oh, what happened? They all multiplied to be the same? So it is inverse because, what did we just fulfill? X times y equals k, right? because they multiplied x times y equals k, that tells me that this is inverse. Now, go back and check the directions because I know we have to say more than just inverse. Write function models for the direct and inverse variations. Okay, so first question to you, if this is inverse variation, what is k? K is 30, because that is the number that I multiplied to. Now, you technically could write this in two different ways. We just found that x times y always equals 30, right? So one way to write this is xy equals 30. If I'm grading that, I'm not going to count it wrong. However, usually when they want the function model, they're looking for the y equals version. And so the y equals version, if I want to get y by itself, I can divide by x. And so this is going to be y equals $30 divided by x. Or, in all honesty, did you even have to solve that like that? What do we have up under inverse variation? What is that first form of the equation? Y equals k over x. If k is 30, it's y equals 30 divided by x. Questions on that? Not horrible, right? Okay. What are your thoughts on C? Divide? Some of them are easier to divide than others, but now when she says divide, am I doing x divided by y or y divided by x?
Y divided by x.
Y divided by x. Does that matter? Yes, because as we are dividing, notice it's y divided by x up here. Okay, so x, in all reality, you could do x divided by y, and that will still tell us it's a direct variation. However, it won't give you the right k value. So that's why you need to be doing y divided by x. So if I'm doing y divided by x, that means the first thing I'm doing is 8 divided by 0.2. What is 8 divided by 0.2? 40. The next one, 20 divided by 0.5, 40. 40 divided by 1.0. You realize that is just 40 divided by 1, yes? Although some of you probably still did it on the calculator. 60 divided by 1.5. Okay. So in this one, we just did y divided by x. All my y divided by x's resulted in the same. So what's that tell me? Yeah, right over here in direct. K equals y divided by x. So this is an example of direct variation. If they ask you for the constant, what are they looking for? My constant is 40. K is 40. What's the function model I'm looking for here? Okay. Y equals 40x is, I think that's what Math Excel would be looking for, if I recall correctly. Okay. And that right there, look up here, guys. What do I have circled? Y equals kx. If k is 40, y equals 40x. If you want to use what we just found, and that we did y divided by x and got 40, do you see how that will get you there? Because if it's y divided by x, you can then multiply that x over to the other side. Okay. You've seen an example of each now, right? I'm going to zoom in a little bit here. Have you figured anything out for D? What? Okay, multiply. 2/10 times 40 is 8. 5/10 times 16, in other words, half of 16. 1 times 8. And 2 times 4. 8. They all multiplied to be the same. So which category does this fit into? Yeah. Go back here to like B, right? When x times y multiplies to equal the same, this is inverse. What's the equation I'm looking for? Okay. Y equals 8 over x. Because up under inverse variation it says y equals k over x. Okay. E. We multiplying or dividing? Neither? Okay. So you're saying we've got some issues? Okay. So I can tell I'm not multiplying because half of 40 is 20, but 1.2 times 12 is going to have something along the lines of 144 in there, throw in a decimal. Okay. And dividing, if we want to go 40 divided by 0.5, that's going to be 80, whereas 10 divided by 2 is 5. You know, I can do some of these, you know, in my head, but do some analyzing. They're not always going to multiply or divide to be the same thing, so it's a neither. Do you need me to write work down at this point? Obviously, first one I did because I wanted you guys to see what we were doing, but a lot of you guys are probably grabbing your calculators and doing the multiplying and dividing to check it out, I'm guessing. So, okay, so that's one thing you're going to see in the homework, any quiz or test. Chart of numbers, identify it as direct or inverse, being able to identify what's your K and what's the equation representing the situation. So, good reason to become familiar with your direct and inverse variation equations. Okay, example 2 is a, what, 3-part problem if I recall? All based on the initial problem here. Suppose x and y vary inversely. So what are they stating right here? They're stating that we are working with an inverse situation. They're not asking what it is, it's inverse, period, end of statement. So suppose x and y vary inversely. X is 4 and y is 12. So x equals 4 and y equals 12 is one set of numbers that represent this inverse situation. So, example A. What function models the inverse variation? So kind of what we did up above. What function models the inverse variation? So I want you to write an equation. In order to write an equation, what do we have to know? K. How do we find K? You times xy. And how do I know that I times xy? What's this? Yeah, it says above. What's it say under inverse variation?
K equals x times y.
Yeah. K equals x times y. Was I given an x and a y value?
Yeah.
Yeah. So K equals 4 times 12 So k equals 48. Now, it didn't just ask me to find k, though. It wants the function that models this situation. So what's the function I'm looking for? Okay, y equals k over x, which is going to be y equals 48 over x in this specific situation. If you want to think about it as x times y equals 48, because that's what I just did. I did x times y, got 48, and then I divided it to get y equals. That works as well. Again, should not be too horrible of a problem if you look at those equations up above, right? Rely on looking at those equations right now. B. What does the graph of this function look like? I don't know. Do you guys know what this graph looks like? Do I expect you to know what it looks like right now? No, I don't. Okay, so what's the plan when you get something and you don't know what it looks like? Okay, well, we're going to need more than 1 point, though. Okay, so can we work on setting up an XY chart? Okay, that's what we're doing here. We're going to set up an XY chart. Now, the idea is use one of your graphs from above, or one of your equations from above. You can use the equation we just wrote of y equals 48 divided by x, or you can use the idea that x times y has to equal 48. Am I going to like all x values in this situation? No, I'm not going to like all x values in this situation. So I'm not going to do quite my normal like -2, -1, 0, 1, 2 type chart because, well, first of all, 48 divided by 0. Not possible. You cannot divide by 0. I cannot take the 20 of you that are in here and divide you into 0 groups. I can put you in 1 group, but I cannot physically put you in 0 groups. Okay? I have to put you in at least 1 group. So I can't divide by 0, so I don't want 0 on my XY chart. This graph doesn't exist at 0. Okay? 1 and 2 would be good, but I'm also going to need some more points than that. Okay? I want numbers that are going to nicely divide by 48. Now, in all honesty, to be able to get a good idea of what this graph looks like, I'm actually going to use that, xy equals 48. Meaning, can you come up with numbers that multiply to be 48? 6 and 8? 24 and 2?
12 and 4.
48 and 1, 12 and 4. I've kind of lost track at this point of what we have and don't have, but
48 and
3 and 16. Okay. 48 and 1. Is that different from 1 and 48?
No.
Okay. And the idea that 1 times 48 and 48 times 1, those are not different. But in an XY chart, is 148 different from 48 1? Yes. Okay. So, I'm going to list some of these now. I'll be honest. Am I going to graph all of these? No, but I'm trying to get you guys to see the full picture here. So, you guys said 1 and 48. I think I heard 2 and 24, didn't I? I heard 3 and 16. I heard 4 and 12. I heard 6. I was just going to say 5 doesn't go, right? So skip over 5. I heard 6 and 8. Now, reverse all these. Okay. So besides 6 and 8, we also want to think about 8 and 6, 12 and 4, 16 and 3. I'm going to make another mini column over here. 24 and 2, 48 and 1. in all honesty, those technically all graph to form this equation, right? I'll be honest. I'm not going to count up to 48. I'm not going to count up to 24. I think I can hit 16 on this graph. Not saying those aren't important numbers to think about, but I'm not going to actually graph them. Okay? Now, if I considered all options,
because like -2, -4 equals 48.
okay, so I agree there's some decimals in there. I'm going to ignore decimals. Okay? I'm just going to go for whole numbers because that's what's easy to graph. A positive times a positive results in a positive. Also pointed out is a negative times a negative results in a positive. Meaning, you guys just gave me this big old list, right? Well, if I skip over the ones I'm not graphing, if positive 3 and positive 16 work, so does negative 3 and negative 16. Negative 4 and negative 12. Negative 6 and negative 8. Negative 8, negative 6. Negative 12, negative 4. Negative 16, negative 3. Sorry, that one was written a little weird. Okay. Now, so technically, my graph is not a great graph to be on here because this graph is only set up for quadrant 1, positive numbers, right? So what I'm going to do is I'm just going to extend my graph, or extend my axes. And I'm not going to be very specific on the other set. But I'm just going to extend my y-axis down, my x-axis to the left. Okay? So I just did extensions of what's already there. Oof, should have used a ruler. Yikes. Let's worry about the quadrant 1 options. Positive quadrant. So, 316 says we're doing what? Right 3, up 16. 412. Right 4, up 12. 6, 8. Right 6, up 8. 8, 6. Right 8, up 6. Right 12, up 4. 16, 3. Hopefully I got all my dots in the right spot there. And technically there'd be there's more dots continuing on, yes? Because I opted not to graph 148, 224, and then reverses. What's this graph doing?
Going down. Curving, yeah.
There's a curve happening here? Take a guess here, guys. This graph is going to go infinitely up and infinitely off to the right. What would you guess I'm never going to cross? The x-axis. I'm never going to go below the x-axis in quadrant 1, and I'm never going to go to the left of the y-axis in quadrant 1. That x and y-axis act as asymptotes, which we'll talk more about in this chapter. Now, that's my quadrant 1 part of this graph. Where are numbers like -3, -16?
They're in the quadrant, like diagonal.
Okay, the diagonal quadrant, because you would go what? Left 3, down 16, or if you reverse it, left 16, down 3, which is quadrant number 3. 1, 2, 3, 4. Go counterclockwise. Now, I'm not going to count exactly. Can you just sketch? Are you okay if I just sketch that piece of the graph in? I'm going to go with, okay, it would be a replica of what's in quadrant 1. Okay? That is my replica of quadrant 1. So, all of these graphs we do are always going to be in 2 diagonal quadrants. This one was quadrant 1 and 3. Okay, real quick. C. What is y when x equals 10? How can I figure this out pretty easily? 48 divided by 10. Because up on part A, what did we do? We wrote in equation. Y equals 48 divided by x. So y is 48 divided by 10. And 48 divided by 10 is 4.8. Is that technically another ordered pair on my graph? Yeah, technically we could graph the ordered pair 10, 4.8, and it should land on that curve. Now it's a decimal, so am I actually graphing it? No. Okay? Okay, guys. We will continue tomorrow in the notes. We will start tomorrow doing another example, similar to what we did. And then we also need to talk about combined variation, where we talk about direct and inverse variation, and also something called joint variation. So we will work on that stuff tomorrow. You're welcome to start homework, but it won't be due till Friday.